This is a video on Chapter 1, Section 1.5, finding the equation of a straight line. In Section 1.5, we were introduced to two different formulas, the first one being slope-intercept form and point-intercept form. So what is slope-intercept form? Slope-intercept. And if you haven't memorized this already, I would do so. Y equals mx plus b. And the other one being point slope. Y minus y1 equals mx minus x1. These are the two formulas we can use to find the equation of a straight line. And both will work. Both will get you the same answer. They're just written a little bit different. We know that m, again, is our slope. So m is always the slope. And initially, in some of the problems, the way they'll write it is they'll give you x1, x2, y1, and y2, and then they'll ask you to find the slope, and then you would solve for slope-intercept form or point slope. Sometimes they'll actually give you the slope already, and then you can go ahead and just use one of these two formulas. We're going to do problems and examples of both types to be familiar with it. But another thing we have to keep in mind is if they were to give us two different functions and they were to tell us they're parallel or perpendicular to each other, what does that mean? Well, parallel and perpendicular are pretty explanatory. Parallel means that they're running together. Perpendicular means that they're running opposite each other. The way you would write the slope based on whichever type is written will be different. So let's say they gave us the example in the textbook. They gave us f of x equals m1x plus b1, and then they gave us g of x equals m2x plus b2. And the initial ones, they'll say, oh, it's running parallel. So if it's running parallel, that means their slopes are going to be equal to each other. They're going to be the same. So that means m1 is be equal to m2. But if they're perpendicular, this means that m1 is not going to be directly equal to m2. It's going to be equal to 1 over m2. So depending on how they present the lines and or the functions and how they're related to each other, you're going to write the slope a little bit different. But most of the problems, you're not going to be dealing with two of them together. We're just going to be solving for one. We're going to get the slope and then get the point slope or y-intercept form to find the equation of the straight line. But this is a good thing to keep in mind if you were doing some of the homework and they were presenting you a question like this, or if they were to give you two functions. So let's do a couple examples. Number one. Let me write it out. This first problem, find the equation of a linear function, f of x equals mx plus b, given that the graph passes through our points. This means that we will have to calculate our slope, and then we can either calculate via the slope-intercept or point-slope form. And how do we solve for a slope? Well, the thing that we've been using over and over, we know that the average rate of change is equal to our slope. And we know that our formula is m equals y2 minus y1 over x2 minus x1. And then we need to label our information that they gave us here. So we know that the variable next to the f is always going to be their x, right? So this means it's going to be x1, and this one's going to be x2. And then the other variables are always our y. So that means this one's going to be y1, and this is going to be y2. Now we have all the parts we need to solve for the average rate of change. So I'm going to set it up. Just going to put my values into the formula. And now we can solve. But notice we have two negatives here. This means that this is going to become actually a positive. The negatives will cancel out, and then what's left behind is the positive. Now we just do the math for it. So -1 minus 5 gives me -6. And then 2 plus 3, well, we already know that's 5. Now we know that our slope is -6/5. Great. But we're asking for the full extent of the function, so the full function. Now we know what our m is, so -6/5. We have our first piece. Now we have to find our y-intercept in this case. We can solve this using point slope form, or we can use the y-intercept form. I'm going to start by showing the point slope form, and then we'll do the y-intercept form. Y minus y1 equals m, which we know is what we just found, minus x1. Y minus y1, well, let's look our information. Y1 is 5. Our slope is -6/5, x, and my x1 is -3. And I have to incorporate the sign into the actual equation here, so this is actually turned positive. Now what I do first is I want to FOIL or move this guy into the parentheses. So that's going to become -6/5x. And then when I multiply the 6/5 times 3, because you know it's positive now, what we're going to get is -18/5. And the reason why it's negative is because there's a negative sign in front of the -6/5. And also, we can do this easily in our heads. So if you're like, oh, how do I multiply the -6/5 times 3? We just multiply the top two numbers and we get 18. The 5 stays the same because you notice in our slope and this is the same denominator. Well, now what do I do? We want to isolate the y, right? That means I want to move this 5 over to the other side. And it's not going to be joining up with the slope. The slope is going to stay on its own. And then when I move the -5 or the -5 across the equal sign, that means it's going to be turned positive on the right-hand side. Now we can simplify. To simplify, we can easily use our calculator to add these together, or we can do it by hand. And how we do that is I just make the bottom over 1, and then if I wanted to get the same denominator as the left, I need to multiply top and bottom by 5. This means I get 25/5. So that means now I can add it to the -18/5. The denominator is going to still be 5, but then when we do the math here, we get 7/5. Now we can write it in this form, simplified, x plus 7/5. And the last step that we need to do is we need to add f of x equals -6/5x plus 7/5. And this is the full equation for our linear function. Okay, now if I want to do y-intercept form, let's set that up. Intercept form is y equals mx plus b. And you can use either the x1 or the x2, but I usually use x1. Y equals our slope. This is my x1 here, which would be -3 plus b. We're trying to find our y-intercept form. This also means that I have to use my y1 here. So that y is replaced with the 5. Now we're ready to solve. So we can do minus 6 over 5 times negative 3, and we get 18 over 5. Same thing, same math again. Because we have two negatives, they become positive. And then if I want to get b by itself, I have to move the 18 over 5 over. Changing the sign. And if you notice, we have the same math that we had in the point slope form. So make it over 1, times it by 5, 25 over 5, and then we just do the math. We're going to get the same exact thing. Meaning that our function is the same exact answer. Meaning regardless of which formula you use to solve, you're going to get the same exact answer. I think personally the intercept form is a lot faster and quicker, less steps, but either way will work. Let's do a second example. We need to find the equation of a linear function f of x equals mx plus b, given that it passes through our 2 points with a slope of, so that means m is 5 over 6. And then we label our points x1 and y1. Let's use point slope. Y minus y1 equals m, x minus x1. And we just put our points in. And this will turn positive. FOIL 5 over 6x. And then I'll do the multiplication. So 5 times minus 4 is minus 20 over 6. And then I want to move the 2 to the side to isolate y. And then when you move the 2 over, it turns it to a minus 2. And one thing I can do here is I can actually reduce the 20 and the 6. If you wanted to, you could reduce it. I'm going to show 2 ways on how to do it. So you could reduce the 20 over 6. We know that that will turn into minus 10 over 3. You can reduce it. And then we could solve like this. Just number 1 times by 3, top and bottom. So negative 10 minus 6 gives us negative 16. Over 3, which is correct. But if you didn't reduce it, an initial step would show how it would be if it's not reduced. So this would be, the final answer would be 5 over 6x minus 16 over 3. That's our answer. Let's say I decided to reduce it differently. Let's show that. So let's say I kept it as a 20 over 6. Minus 2 over 1. And I multiplied top and bottom by 6. that means we would get negative 12 over 6. And then we could do the subtraction, minus 32 over 6, which is technically correct, but this can also be reduced. So if you wanted to, you could actually put this directly into your calculator and it reduced it for you, and it gets reduced to negative 16 over 3. So if you notice, it's the same answer that we got as the other solution, or solution way. But then how do I reduce that? How do I know how to reduce 32 over 6? Let's approach that. To reduce the 32 over 6, what we want to do is to find the common denominator, or the common divisor. So that means they are both divisible by 2. You just divide by 2 here for both of them. We know that negative 32 divided by 2 gives us 16, and then 6 divided by 2 gives us 3. Both ways on how to get to your solution are correct. I'm just showing you there's many ways on how you can solve it. And if you're more comfortable with it, you can solve it by using the y-intercept form. So this is solving using y-intercept form and point slope form.